is Koby Close. I'm a senior analytics engineer.
This is Venkat Chinni. I am a software architect. I'm part of the enterprise architecture team.
We have a bunch of enthusiasm and excitement around GenAI at KW right now. And so our current kind of cycle is focused on establishing some good patterns and best practices, expectations across teams so that we can build on all that excitement and momentum, deliver quickly in the future. Our main consumer and customer as a tech team is our KW agents. And so a lot of those use cases, those future use cases have to do with improving efficiency around our CRM tool and just empowering agents to be more efficient in their work. And so our initial use case that we're using is an internal efficiency tool for the tech department. I'm excited about it because it touches a ton of different personas. Pretty much anyone in the tech department, there's some tool in there that's going to help them. We've got Jira tools, which are great for like PMs and Scrum Masters, some good data tools for developers and analysts, even up to executives for answering some data-related questions. And for us, it's been a great opportunity to establish some ideas around like scaling, security, evals on the Arise platform, and then also take on some cool technical challenges, working mostly with migrating all of our tools to MCP servers so they're reusable. And then a big technical challenge we can talk about is our text to SQL product that we're continuing to work on. We actually started our partnership with Arise on the MLOps platform. And so just quick background on that, we had a computer vision project we were working on through the data science team, and we needed to build some in-house solutions that were compatible with Vertex, and Arise offered that as a solution for us.
Evals are critical because AI changed the quality model that we relied on for decades. In traditional software, you can map every user interaction to a predictable API call. The system always behaves the same way, and QA can validate those deterministic paths. But with AI, the user's raw language flow directly into the model. It has to interpret the intent and meaning in real time, and that's a non-deterministic thing in nature. So traditional QA breaks down there. You can't just click through test scripts and say it works, right? So that's where evals come into picture. And they're the only way to know if your system is actually working for real people or not. But the challenge is engineers alone can't write effective evals because we don't talk the way users do. Like, for example, an engineer might say, what's the listing price for 123 Main Street? But a real agent, like a real estate agent, would say, what's the house on Main going for? So the approach is more product led. So we bring product teams directly into the evaluation process because they know the slang, the shorthand, the actual vocabulary of users. And on top of that, we layer in risk management evals like hallucination checks, toxicity filtering, and the user frustration scenarios and all that stuff. So the way I see it, evals aren't a one-time exercise where you're going to implement and then just let it run. That's like a continuous loop where new user queries feed back into the system and evals evolve as the product evolves. So it's like building a new organizational muscle kind of thing where product-led AI quality assurance is going to be a thing. And without that, simply you can't succeed in production.
I mentioned earlier we've had some hurdles to overcome with text to SQL, and I think that was a big big wake up for me. I work on our enterprise data lake, and so I have a pretty good understanding of how that data is laid out, some of the nuances in there, and so seeing our chatbot struggle with those scenarios was really interesting for me, and not quite what I expected. So the way we've approached that is we started by turning the bot loose on the entire data lake. And what we found was that it was having a hard time identifying the right tables to query. And then even if you kind of coached it to the right set of tables, writing those multi-step joins or adding any complex business logic was just outside of its reach right now. And a lot of that had to do with just our documentation within BigQuery. We have great documentation elsewhere, but not on the tables themselves in a way that was really accessible for our agentic solutions. And I think that's where we kind of fell short. And realistically, we weren't going to be able to manually go back and resolve all those issues. So we had to come up with some other approaches. We've tried things like a known good SQL library. So anything that the bot wrote that we liked or anything that we were using frequently, we were adding that to try to give some direction or shortcut some of the complex query writing. We added some table descriptions on like key tables or key fields that it was struggling to identify. We also just limited the scope. We just said, hey, here are the 20 most popular tables at the company. Like maybe this will work. And we just continued to see that that performance not really meet our expectations for us to really turn this loose to someone who maybe doesn't have that technical understanding like we do as we're developing. And so that was surprising. Through some research, we've got a solution that I think is pretty promising so far. We created what's essentially a semantic layer for the bot by writing views and only exposing those views to our solution. The advantage there is all those joins in business logic have been taken care of in the view definition. We're relying on the expertise of our business intelligence team to really assemble that data in a way that aligns with company expectations. And we've limited the scope so far by only targeting data that's already available through other BI reporting tools like Tableau, assuming that that's going to meet most of the requests of our users because they're probably already using Tableau for these things, while just adding some efficiency. You don't have to open an entire platform, add filters just to get a single number. And so making progress there, but I was surprised just at the hurdles that came with that, even though I do feel like our data is fairly well organized. Just that level of detail that AI requires was surprising.
So I'll start off with this MIT study, right? So I read about this where 95% of AI initiatives fail to generate profit. And the reason is very clear. It's very easy to prototype something, but if you don't build it with the right foundation, it crashes. So if I were starting fresh today, I'd be building the boring stuff first. That means evaluation frameworks from day one, literally from the first prompt, not after first deployment. Then I would define the non-functional requirements like latency budgets, fallback strategies, error handling. This helped mitigate or completely avoid scenarios like what happens if your LLM is down or if you hit rate limits. And the next piece will be observability and cost tracking. We know every LLM call costs money, and without good tracking, you either get a shocking bill or you're forced to shut down something that's actually successfully working because your ROI isn't clear. So and on top of that, for enterprises, governance and compliance also belong to the foundation, like audit logs, PII handling, explainability, kind of thing. And once those guardrails are built in place, or at least had a thought around moving forward, then I would pick out a very narrow use case and get it completely right, not just functionally, but operationally. And then I would expand with different use cases. And that's how you move into the top 5% of AI initiatives that actually succeed. So, and what to avoid moving fast without a strategy. In traditional software, you can patch a bug overnight, but in AI, one bad response can destroy the trust from the users. So that's one thing. And I'd also avoid chasing novelty use cases too. Instead, I would align projects with business workflows that actually matter. And that's how you build something that lasts. An agent becomes system of system once it stops being a single prompt and response and starts orchestrating multiple components to deliver outcome. Look, for example, answering what's the listing price. It's not going to be a single LLM call. The agent might retrieve MLS data, compare market comps, call APIs, apply business rules, and then present the answer. So at that point, it's no longer just an agent. It's coordination of a network of tools, data sources, and business logic. And that shift brings new responsibilities too, like reliability engineering, observability across multiple calls, governance around data handling, and evals at every layer, not like from retrieval of a query to the final response. So for us, an agent becomes a system of system the moment it orchestrates multiple moving parts. And at that stage, we will treat with the same rigor as any other enterprise system. At KWRI, the agent engineer is going to be like a hybrid role that bridging the AI capabilities with business value. They need stronger software engineering fundamentals, but also understand how the models behave, how to design a prompt, and when to use strategies like either retrieval or orchestration kind of thing. Um, they're not just building features, they own the reliability of the AI system, and that includes prompt designing, RAG pipelines, observability, and even making architectural decisions such as when to call APIs versus models. So, what sets them apart from a typical ML engineer is the focus itself. So, ML engineers like they train models while agent engineers orchestrate them, evaluate them, and get them into production in a safe, sustainable way. They also partner closely with product and compliances teams, acting as a translator between what's technically possible and what creates business value. So, in short, an agent engineer is the architect of trustworthy production-ready AI agents. So that's how I see it.
We have kind of a multi-step tool call for our text to SQL solution around searching for the right tables, searching through a known good query database, and then actually writing and executing the query. And by using the Arise platform through our development process, we saw that the agent was struggling to call those tools in the right order in a way where it wasn't making wasteful calls. And on the surface, it looked like it was performing fine because it was returning a query that matched what we wanted. It was delivering the data, but only by digging into the actual spans were we able to see that inefficiency that was probably going to start to rack up a pretty big bill as you're making excessive calls. And so there's just one example where being able to dig into the details while we were developing really helped us be more efficient.